Bivouacked deep in the Filch-Narona ice shelf, geologist James Smith of the British Antarctic Survey faced a daunting challenge. It was southern summer in Antarctica, but the conditions were anything but mild. For nearly 3 months, Smith endured freezing temperatures, sleeping in a tent, and surviving on dehydrated food. His mission? To uncover the history of the floating ice shelf by collecting seafloor sediment locked under half a mile of ice. The task was monumental. Smith and his team melted 20 tons of snow to create 200 liters of hot water, which they pumped through a borehole to penetrate the ice. It took 20 hours of painstaking effort to melt their way through, inch by inch, finally breaking through to the seafloor below. The next step involved lowering a sediment collector and a GoPro camera through the borehole. But when the collector returned empty, not once but twice, it seemed their efforts might be in vain. Reviewing the footage that night in his tent, Smith discovered the problem. The camera revealed a descent through 3,000 feet of blue-green ice, then into dark seawater. He traveled another 1,600 feet to the seafloor, showing light-colored sediment. What they had been seeking, but also something unexpected. A large, solitary rock. The rock wasn't just any ordinary boulder. As the camera scanned its surface, it revealed a thriving ecosystem, life in a place scientists thought could not sustain it. "Bloody hell!" Smith exclaimed. The rock, located 160 miles from sunlight and hundreds of miles from any known food source, should have been barren, yet it was covered in a film of bacteria, sponges, and peculiar stalked creatures, defying all expectations. Smith shared the footage with his colleague Hugh Griffiths, a biologist at the British Antarctic Survey. Griffiths noticed microbial mats, a layer of bacteria on the rock, along with alien-like sponges and other strange animals clinging to its surface. Some sponges were cylindrical, hugging the rock, while delicate filaments covered parts of it, possibly hydroids or another bacterial component. This rock sat 160 miles from the nearest edge of the ice shelf, hundreds of miles from sunlight or any obvious food source. Life here shouldn't exist, yet it thrived. "It's not the most exciting-looking rock, if you don't know where it is," Griffith said. Its improbable location made it extraordinary. Life on the sea floor typically relies on marine snow, a steady drift of decomposed organic material from creatures living above. In Antarctica's productive waters, this detritus sustains deep-sea ecosystems. But the animals on this rock had a major disadvantage. Buried under half a mile of ice, they couldn't depend on a vertical flow of food, nor could they move to find sustenance. Sessile animals, stuck to one spot, typically need a reliable food source, a luxury these creatures seemingly lacked. The team proposed an explanation. Marine snow was traveling horizontally, carried by currents under the ice. Charts of nearby currents suggested a plausible source of organic material 390 to 930 miles away. While unusual, it wasn't impossible. Dense Antarctic water sinks and radiates outward, creating currents that can carry organic matter across vast distances. This lateral drift could be sustaining the creatures on the rock. However, without specimens, the team couldn't confirm what these animals ate. Some sponges filter organic particles from the water, while others are carnivorous, feeding on tiny animals. Were these killer sponges preying on unsuspecting creatures in the darkness? The camera showed no mobile animals, but the question of predation remained unanswered. Despite the mystery, the rock's location seemed ideal. It wasn't buried under sediment, and enough food appeared to reach it. "It's got just enough food coming in, and it's not getting buried," Griffiths noted. Ripples in the surrounding sediment further supported the idea of currents delivering sustenance. The mystery of how these stationary animals arrived on the rock deepened the intrigue. Did they spread locally, hopping from one boulder to another under the ice shelf? Or were their ancestors from hundreds of miles away, near the ice shelf's edge, releasing eggs and sperm into the currents that carried them to this isolated spot? Without specimens to analyze, the researchers could only speculate. The potential age of these creatures added another layer of fascination. Antarctic sponges are known to live for thousands of years, suggesting this ecosystem could be ancient. It's possible the rock was seeded with life long ago and periodically refreshed by currents, bringing new organisms over millennia. The broader implications of this discovery were just as compelling. Was this rock a one-in-a-million find, or are such ecosystems common beneath Antarctica's vast ice shelves? Smith's lucky drill site may not have been a fluke. The ice shelves cover an area of 5,600,000 square miles. Yet scientists have only explored an area the size of a tennis court. If similar ecosystems exist elsewhere, they could harbor unique and resilient life forms adapted to extreme conditions. But time is running out to uncover these secrets. As global temperatures rise, Antarctica's ice shelves face increasing instability. There is a potential that some of these big ice shelves could collapse, Griffiths warned, and we could lose a unique ecosystem. The team's discovery highlighted just how much remains unknown about life in Earth's most remote and inhospitable places. With the right conditions, currents delivering food, no predators to threaten them, and a stable environment, life finds a way to persist, even in the unlikeliest of places. Yet the questions far outweighed the answers. What do these creatures eat? How did they survive in darkness, isolated from conventional food sources? Could other mobile animals like fish or crustaceans live nearby, unseen by the camera? Only another expedition could solve these mysteries, and even then, the logistics of such a mission would be daunting. For now, the rock's secrets remain hidden beneath half a mile of ice, waiting to be explored further. This remarkable discovery raises profound questions about the resilience and adaptability of life. The researchers were left to wonder whether the boulder was an anomaly or part of a hidden network of ecosystems beneath Antarctica's vast ice shelves. If similar communities exist, they could reveal untold stories about survival in extreme environments. Yet, the urgency to investigate is mounting. Antarctica's ice shelves are under threat from a warming climate, making their stability increasingly uncertain. The collapse of these icy barriers could destroy unique ecosystems before scientists have a chance to study them. For now, this single boulder stands as a testament to the mysteries waiting beneath the frozen expanse. Smith and Griffiths' work underscores the importance of exploration and the potential for serendipitous discoveries. From the outside, the rock might appear unremarkable, but knowing its location, surrounded by darkness and miles of solid ice, transforms it into a symbol of life's ability to persist against the odds. Now, this frozen frontier holds its secrets tightly. But with continued research, we may one day uncover the full story of the boulder and its resilient inhabitants. Until then, the discovery reminds us of the unyielding drive of life, even in the face of impossibility.